Hi everyone, my name's Karen, and I'll be walking you through how to make a really cool dungeon crawler-esque role-playing game. This will use everything you've learned about Python so far, and we're also going to add some new concepts such as classes and inheritance. And because this workshop there's a lot of stuff to cover, so we're going to split it into two parts. In this first part, we're going to go over classes and inheritance, and briefly introduce the mechanics of the game, and then in the second part we'll dive deeper into the game itself. Okay, let's begin part 1. Alright, so before we talk more about the game, we need to first cover some background concepts in classes and inheritance, which are more advanced but powerful tools you can use in object-oriented programming, such as Python. Alright, the first key concept we're going to cover are objects and classes. So objects in programming you can think of them as very similar to objects in real life. So for example, a car is an object in real life. And in both cases, objects have attributes and behaviors. So in the case of a car's attributes are things that you can observe or measure about it, such as its model or its size. And it can also have behaviors, which are things that it can do, such as driving or honking. So in Python, it's the same thing. Any object has a list of attributes and a list of behaviors that it can perform. So where do we define attributes and behaviors for a given object? We do that within the object's class, which is just a block of code that lists all the object's attributes and behaviors. So think of it as like a blueprint for that object. And one blueprint, just like how one blueprint for a car can be used to make multiple cars, one class can be used to create multiple objects. Alright, let's go through an example of making a class and then creating an object from that class. So here we made a class called rectangle. It's going to create a rectangle object. And here's how we define a class. We use the class keyword followed by the name of our class, rectangle, and then within this block of code we're going to list attributes and behaviors of our rectangle. So for now, let's focus on attributes. So all attributes are defined within a constructor function, which is this init function shown here. And essentially what it does is, this is the function that's called whenever we create a rectangle. So when we create a rectangle, Python's going to go into the rectangle class and ask it, how do we create a rectangle? What kind of ingredients do we need? Well, we decided to have two attributes for our rectangles, width and height. So that's two arguments that we need to add to the constructor. We need to tell it what our rectangle's width and height is, and then it will set its own width and height equal to the two numbers we specified. So I wouldn't worry too much about the syntax here. Self just means that it's referring to itself, its own class, and the underscore here makes these private variables, which means you can't access them from other classes. So what's going to happen? Here we created a rectangle by calling the rectangle class and giving it the arguments the constructor needs, 50 and 40. So 50 is our width and 40 is our height. So once we do this, it's going to return a rectangle object with our width and height that we specified here. And then it's going to save that in a variable called myRectangle. So from then on, we can now refer to our object as myRectangle. Now let's add some behaviors to our rectangle class. So behaviors are essentially functions, right? And they do something, carry out a certain task. So here we're going to add two simple behaviors into our rectangle class. We're going to add a function called getWidth and a function called getHeight. Because remember I said before that width and height are private variables. You won't be able to access these numbers outside of the class, so we'll need to make functions that will return them for us. So here they are, very simple functions. The only difference here is that we have a self inside the parentheses for each function. And that's just proper syntax when declaring functions inside a class. it means that whenever you call the function, you have to use the name of the object dot whatever the function is to call it. So for example here, we made a rectangle from last slide, it's the same thing, and then we're going to get its width and get its height, call these two behaviors from within its class, and then we're going to print whatever these two functions return, and it's going to return the rectangle's width and height, 50 and 40. So the final conceptual topic I want to cover is something called inheritance. And inheritance occurs when you have subclasses of a parent class. So it's called inheritance because just like you inherit genes from your mom and dad, subclasses inherit attributes and behaviors from their parent class. So as an example here, we're going to create a subclass called square, and its parent class is our rectangle class. So here's how we do it. We declare a class called square, and to let Python know its parent class is rectangle, we put rectangle in the parentheses here. And square is going to have its own constructor. And the difference between squares and rectangles, right, is that squares have all sides the same length. So we don't need to specify, we don't need different arguments for width and height. We just need one argument, side length. And width and height will both be equal to side length. Now, inside this constructor, we could have set self.width, self.height equal to side length like in the rectangle class, but here I'm just being lazy and I'm calling the constructor for the rectangle class to do it for us. So that's what super means. It's calling the parent class and it's calling its constructor init function. And it's setting the width and height both equal to our side length. And I'll walk through this more step by step in the next slide. So, and then down here is how we create our object, a square object. Like before, we call the name of the class, and then within the parentheses, we give it the arguments it wants. So for a square class, it only requires one argument, side length. So we gave it a side length of 20 and assigned it to the variable mySquare. And so here's everything we've done so far. We defined a rectangle class. It has two attributes, width and height, and it has two behaviors, get width and get height. And then we defined a subclass of rectangle called square. Its constructor here calls the rectangle's constructor, so that when we create a square object, essentially what we're doing, when we execute this line of code, Python's going to see this and be like, oh, how do I create a square? Well, we go to square class. It's the blueprint for a square. In the square class, there's a constructor that tells us how to create a square. What does the constructor say? It says, go to the parent class's constructor, and it'll tell you how to create a square. So we go to the parent class's constructor. It wants a width and a height. Well, we gave it that. We gave it side length for both its width and its height. And what's side length? Side length is 20. So we just created a square with a width and height of 20. And then we can get the width and get the height of mySquare and print them out. Now you might be thinking, wait, we didn't have these two functions in the square class. Well, remember that square is a subclass of rectangle, so it inherits all the functions of the rectangle class. So it by default has both of these functions, even though they're not listed inside its class. Alright, now that we've gotten the background concepts out of the way, we can now dive into the game and have some fun. Alright, first I'm just going to show you how the game works. Alright, so we just ran our program and this is the first thing it asked for. It asked for our character's name. It could be whatever we want. So since I'm a Lord of the Rings fan, I'm going to go with Aragorn. And choose a class, I'm going to say Rogue. So we just made our character, and our character has these stats specific to the Rogue class. Alright, so now the game begins. We're at the crossroads and we have a couple of choices. We can fight, we can use an item, we can visit the store. So I have neither items nor money, so I'm just going to fight. And I encountered a goblin for this. It's faster than me, but I think I can beat it. Let's keep fighting. and it died, and we earned 80 gold as a reward. Cool. Well, we have some money now, so let's visit the store. Let's buy a health potion. A large health potion. And I still have 30 gold left. Let's also buy a small one. Alright. All stopped. Do another fight. The Brave. Oh no, I lost 1 HP. I managed to kill it. So, I've lost some HP. Let's use an item, our health potion, to restore that HP. I'm gonna use a large one. I think I lost 5 HP back there. Let's do that. Cool. Now I'm at full health again. And so we can continue doing this over and over until either your character dies or you want to exit the game. When we exit the game, it'll give us our score of how many monsters we killed. So that's the gist of how this game works. Now that you've seen how the game works, let's try importing it and tinkering with it ourselves. Here's our import link. I'm sure you're all masters at importing things at this point. And just make sure that when you import it, you see all 4 of these files in the menu bar, because you'll need all of them to run the game. First, let's look at the file called characters.py, where we define all our character classes and the attributes and behaviors they each have. So go ahead, open up characters.py, and I know it looks like a lot of code. There's actually a lot of code in this entire thing, but not to worry. We're not going to go over all of it in detail, and you don't need to know about all of it in detail either. We're just going to talk about the important parts. So anyway, in characters.py, we're going to have one character class that will contain attributes and behaviors that are shared across all characters. And then we're going to have 3 subclasses of that character class, and these represent the subclasses that you can pick as a player. So we have a knight, we have a mage, and we have a rogue subclass. So to clarify things, here's like a graphical representation of our subclasses and our parent class. So remember how we talked about in the beginning we had square as a subclass of rectangle? Well, here we have 3 subclasses, knight, mage, and rogue, of character. And within our character class, we're going to have some attributes and behaviors. Attributes such as the name of the character's health, attack, speed, and also behaviors. So a character can attack another character, it can take damage, and it can heal. And remember the rules of inheritance. Because knight, mage, and rogue are subclasses of character, they're each also going to have all of these attributes and all of these behaviors. So here's what the code looks like for all of our classes. Character class has the most code because within it we need to define all the attributes and behaviors that will be inherited by the subclasses. So inside the character constructor, we're going to have all these attributes that we talked about having before, like name, health, dodge, chance, speed. We're going to assign them to variables in this class. And then any subclass that inherits from this character class is now going to have all of these attributes by default. So really, for a constructor in the subclass, all you need is this one line. We call the parent constructor, and we tell it the value of all of these attributes. The name will be whatever the player decides it will be, so that's why this is the one argument that this constructor still needs to take. But otherwise, everything else is predetermined. All knights are going to have 15 health points, for example. All knights are going to have 3 attack power. So all of this is going to go into this constructor, and it's going to set all of these attributes equal to the values we defined here. And the same goes for the other 2 classes. Now let's dive into one of the behaviors that a character can have. It's called attacking. It happens when one character, our character, attacks another character. So this attack function is what handles those situations, and this function is found inside the character class. And it's going to be inherited by all of the subclasses of character. So the function itself is pretty simple. It takes in one argument, other, and this other represents the other character object that is being attacked by this character. And so when we attack, we want to know how much damage was done by the attack. And to make things interesting, I set it to equal some value plus or minus 2 of the character's attack power. So for example, if the character's attack power is 4, then the damage done by this one attack can be anywhere from 2 to 6. And then this line of code here just makes sure that damage done is not less than or equal to 0. Alright, and then we print this character attacks the other character for how much damage, and then this function here we call takeDamage function on the other character, and this handles how the other character responds to this attack. So in our main method, which we'll talk about much later, we can call this attack function on a character like this. So player is a character in this case, and enemy is also a character. Player is attacking enemy. So this attack function belongs to the player, and in this case enemy is the other character that's being attacked. Okay, so now let's talk more about this takeDamage function. Here is the takeDamage function. It's also found in the character class. It's right underneath the attack function we just talked about actually. So the takeDamage function has one argument, damage, that represents how much damage was dealt on this character. And this function can go one of two ways. Either the character dodges, in which case no damage is taken, or the character fails to dodge. And whether or not it dodges is based on whether this random float generated by this random function here is greater than or equal to the character's dodge chance. So if the character failed to dodge, then it will lose health. The amount of health it loses will be equal to the amount of damage done, and we're going to print that to let the player know. And so that's basically what this function does in a nutshell. And this is all I'm going to cover for the characters.python file. There is definitely a lot more functions, a lot more attributes and behaviors in that file that you can look through. And feel free to look through them. I commented the code as best as I could, but we don't have time to talk about all of it here. So this is the end of part 1 of our workshop. And next part we'll talk more about how the game itself works, like how we loop through all the different rounds of battle and choices that players have to make. See you in part 2.